let's look at another one. All right, you have your sheet with your transformations. Here's my graph, core graph. Start like this, core graph. Asymptote, always start like this. Now, which way is this forcing me to go? X plus 3 in parentheses. To the left. It's next to the X, so it's moving the X sideways, and it goes the opposite way, to the left. I know this point is 1, 0, and I know this is the X 0. So therefore, watch. Take 3 away from this. I can move this to negative 2, 0. Take 3 away from this. I get negative, X is equal to negative 3. I'm going to have to write right over this little piece over here. Sorry. X is equal to negative 3. I just moved everything 3 places. Here's my graph. It has the same look as this. That's not changing. Same look as that. I moved my asymptote. I moved my intercept that we know familiar with all our cores. And I'll change my domain. I also took 3 away from this. So I'm going to subtract 3 here. My new domain is now negative 3 to infinity. Did it change my range? No. And my asymptote is now x equals negative 3. I moved that also. Everything slides. This is called a translation, a slide. Right? Don't worry about the intercepts. I'm not concerned too much about the intercepts right now. Is that you get down your core graph and you worry about which way everything's going and your asymptote and your domain. The domain of a log is what's important. The domain of a log says you can't use 0. You can try that anytime in your calculator. Say log 0. It says domain problem. You have a domain error.
So the transformation.
The trans.
93 is horizontal.
A horizontal shift left 3 units. I guess I didn't write that down. Horizontal shift left 3 units. Left 3 units. Okay? Use the sheet that I gave you with all the transformations listed. Don't put this in your calc. I think it's harder to read off your calculator than I do just making a sketch. Now, this guy is outside of my x. So therefore it's not affecting my x, it's affecting my y. I start off with my basic graph. I know what my domain is, I know what my range is, and I know what my asymptote is. Okay, let me put this up here. This is saying drop this down 5 units. So I'm going to take this point 1, 0 and subtract 5 off of its y. So I'm going to come straight down to 1, negative 5 and just make my graph. Did I change my domain? No x is moved. Did I change my range? No, because why? The range didn't change because it is all real numbers, right? So I don't have to worry about my range dropping down. It's still all real numbers. Did I change my asymptote? I have a vertical block here. Did I move it sideways? So everything else stayed the same. I just took a vertical shift down 5 units. And everybody else stayed the same. Negative 5. I'm on 95. Okay? Now, this guy, order of operations. When you look at the x first, you have to do this thing first. So start with your basic graph. Okay? We're going to do what with this x piece? Shift where? To the right 1. So if I move to the right, am I affecting my x or my y? X. So anything with an X, I have to worry about. I'm going to move this guy here to 2, 0. Sorry, I have to write right over this. So therefore, I'm going to add this guy have 1. So now my asymptote is at x plus 1 because I moved everything to the right. Did I change my range? No. Next, what am I going to do with this guy? Up 2. So I moved this guy up 2. I'm 2, 0. I am now 2, 2. And do I have to change my asymptote? Nope. My domain? Nope. So my domain said I added 1. So my new domain, my new asymptote, and my range stays the same. Yeah? Talk to me, guys. Tell me what it is that is troubling. It's a reverse thinking from your exponential ones because they're inverses. We've interchanged all your x and your y's. So everything that happened in the x in your exponential equation are happening in your y's for your logs. Everything that happened in your range is now happening in your domain. So we've got a little bit of a reversal going on. Okay. These guys, you had to use your log rules. You have 3.5 rules. Your product rule, when we multiply like bases, we add. So a product for logs, we're adding them. Your quotient rule, when we divide like bases for exponents, we subtract the exponents. So you're separating the quotient into a subtraction. Your power rule to bring it down. And your little half rule that we have 3.5 is to get the radical out of there first. So, go through these and tell me which ones you have a question with. Yes?
51, do we put that lowercase g on there, or does it have?
That's an 8. It might not come out very good.
Oh, so do we put that there? Or?
Yeah, that's the base of the log. Yeah. Yep. That's the base of your, whatever your base of your log is, stays with it. And if we separate them, all of them separate to that. Okay. Was everybody okay with this one with the radical sign?
So you basically you could rewrite it as ln z to the 1/2 and then.
Yep. ln z to the 1/2, and then pull it down. Here's all 3 of these guys in 55 are being multiplied. They're all factors. Therefore, we're going to separate them with pluses. Anybody taking the Algebra 2 Regents, this is a great review because there's always 1 on your Algebra 2 Regents. Probably something similar to like 56. Now notice, this is a good point that Gianna brought up. This is log base 6. All of these pieces have to have log base 6. You can't have 2 different base logs in one equation and try to combine them. It's like combining 2 different radicals, adding them together. You can't do that. So they all have the same base. Be careful, bring their exponents down after you separate them. Good? Okay. These were hard. These were the hard ones. Okay, let's take a look at 59. Was everybody able to say that this was 1/3? Bring your cube root into, if I just did this, the cube root of y, you would give me y to the 1/3, right? So if I did the cube root of x over y, you're going to give me x over y to the 1/3. You got to follow order of operations. So now, bring this to the 1/3, bring your 1/3 out, but be careful. Your 1/3 goes through this whole subtraction. So now my rule when I divide is subtract. And either you can leave it like that or you can distribute. A lot of times on the Regents, they distribute. Every once in a while, they leave it with the parentheses. So look to see if it's there. If you're taking the Regents, look to see if it's there. With me, probably get rid of your parentheses, I would say. Now, 61, why is this piece here? X is greater than 1. What does that mean to my equation thing? It's a domain restriction. Good. And the reason they're restricting it is why? Because normally, isn't my domain 0 to infinity? But could I put a 0 here in the denominator? I got another restriction. I have a denominator restriction. So therefore, it's telling me it has to be greater than 1. Okay? It doesn't affect your problem. It just says, by the way. Now, undo what you would do last. Like yesterday, we did this. ln x over y. So we say ln x minus ln y. So ln this group minus ln this thing. Now, this one was a little trickier. This guy's coming down. This one, you probably could have left as that, but if you dead spot that they were factors of a perfect square, which makes it a product because they're factors, then you could separate this out. As long as you like at least got to this point, the perfect squares part, if you can see the factoring, we didn't do one with the factor in it. So if we were able to factor it, when you factor, you have a product, and then you use your product rule on it. Think exponents. When you were multiplying like bases, you're adding your exponents. This one, start here with your divide. Give me a subtract first. Then take this part apart here. Now, technically, we should put parentheses here. But the thing is, you're gonna add left to right anyway. You're gonna go left to right, so you really don't need your parentheses here. If it was last part, then you would need your parentheses. But on the first part, we don't really need it. Oh, we wouldn't on the second if it's plus. Okay. Those two were a little bit more difficult. Questions? Quiet group. All right. I didn't give you 65. I took that one out, right? No, that was a horrible one. Okay. Now you had to condense them back into one. So if this was added, when I was adding my exponents, I was multiplying. So I bring this back to a product. If it says ln, you only put ln once. If it says log log, you put log once. For number 73, you have to bring your power up as your exponent first. Log is the only thing to do there. Look them over. Tell me if you have any questions. Questions? No? I didn't see a lot of these on your papers. Number one, lazy. You've got to pick up an example and look at it. Aaron's smiling. We did these examples in class yesterday. Okay, so when we come back from our break and when we're in the second half, I'm not going to take the laziness as an excuse.
For 77, why? Like, when do you know to put, like,
The three, because of this. This has to say ln. If it's ln, I can pull it out. Right? Because it's ln. Problem is, if there's a 3 here, I really shouldn't. I should get rid of that 3 first. It's got to be ln. So this 3 came from somewhere. Now, if you didn't take it out to the very end, it'd be sitting in here, and it's not a multiply. I need this to say ln before I can combine them. That's what my rules are. So I've got to get this guy out of here. I've got to bring it up. The radical is if this is a fraction. So if this is a fraction and it says 1/2 ln x plus 1, then when I bring this 1/2 up, this meant the 1/2 fraction is the same as a radical, a square root. Then I can just flip this back to a radical. So in yesterday I said radical x would become x to the 1/2 because this is why. Here's a 1 exponent, here's a 2 index. Raise it to your 1 and put the 2 under your fraction. A cube root of x raises it to the 1 and puts the 3 under the fraction. Okay. That's how to get a radical to a fractional exponent. But before you can combine those, remember, they got to say log, ln, ln. As soon as you see something in front of it, you know you got to get rid of that first. That was a very good question. This guy, I'm ln, so I got to divide, a nice little divide. Once you bring it back, you should only have 1 log or 1 ln word when you end. And this one, now, watch your parentheses. Order of operations says, find the largest parentheses, go within here first. So the first thing you're going to do is this piece right here. Your order says parentheses exponent. So work from within your parentheses. This guy was a product because it's an add. So I'm going to turn just this piece into that. That 2 still belongs out here. Kind of like the 2 from before with the parentheses in it. Now, the thing is, you're going to take this 2 and bring it back up here. But it's got to go to both of these parts. Now, if you prefer at this point to do the x squared minus 4, that's fine. Those are your perfect squares. Remember, they broke down your perfect squares? You're putting them back together. So this has to come in here. So I'm squaring my perfect square one. The last thing you're going to do is this minus. This minus says give me a quotient. Now if you waited till over here, you might see it a little better with the perfect squares. If you left it like this, would I be concerned? No. Okay. Good? All right, any other questions on these? You've got to know how to go back and forth. Use your 3 rules, 3 simple rules. We don't really see too much of a need when we're doing expressions, but as soon as we start doing the equations when you come back from this break, we're going to be using these. All right, now, I'm just giving you a little tiny homework assignment so that you just stay up to par with this. Now, if you're graphing a change of base, again, I didn't have you graph your change of base yesterday. I had to do a transformation. If I want to sketch this, it's obviously going to become the same sketch, right? It's going to have a domain. It's going to have my range. It's going to have my asymptote. Now, and my point of intercept. And we're okay with that. Now, if I take this and I want to put this in my calculator just to see what my graph is going to look like. Maybe it's supposed to be a little bit sharper here, a little bit wider. I need two ways. If you have the math key that has change of base, math, change of base, you're going to put in y equal, go to this change of base thing, and then fill in the 7 and the x. Now, if you don't, we go like this. We put a line here. We do log x over the 7 stays below the line. Log 7. and you can graph this. I'm sorry? Because you can't put log base 7 in your calculator, we only get log base 10. If you have the change of base key on your calculator, my yellow ones do, but the 83s do not, the black calculators. Well, only when it's not a 10. Now, log base. On the black calculators, you don't have it. They don't have that software on there. The 83s do not have it. You have to do it the old-fashioned way. Make a line, log x over log 7.
Does that have to be in parentheses?
Well, actually, your calculator will probably give you parentheses like this, and you have to close that. Now, just one other thing, guys. If I do any transformations to these, I think it's far easier if you don't use your calculator. So say I do this, log base 7 of x minus 2. Where is this going to shift? To the right 2. So I think it's far easier to come here at the 3, 0, move this guy 2 at the x equals 2, than it is putting it in your calculator. But I do want you to know how to put a change of base 1 in your calculator. Now, when we go through this, again, you'll do your domains and your ranges. And the ones you have for homework, if you're doing your transformations, go off the graph, not the calculator. Check it on the calculator. Put it in the calculator afterwards to see if, in fact, you thought it was going to be there, that it was there. And there's only one more. This guy. How would I put this one in? Watch. Log 3. If you put this in with your change of base, you would put in 3, and then here, in that box, you would put x divided by 3. Now, if you're going to do this and go like this piece has to stay on top. It has to say log x divided by 3 over log 3. That has to stay together. That can't be separated. I don't think we did any intercepts. Over log base. Does yours say 3 or does yours say 5? 3? Okay. So do you see what I'm saying here, guys? Don't separate that fraction. That fraction has to stay on top.